This last video is brought to you by a rather angry looking Han Solo. So what we're going to do now is something a little wonky. Uh, really, our goal here is to get you comfortable manipulating expressions with logarithms, which really means you getting comfortable using logarithmic or properties of logarithms to manipulate expressions. So here we're saying there's some log base a of 2, which is equal to 0.301, and then the log base of the same thing of 7 is this, and log base a of 11 is this. We could do some work and solve for a if we wanted to, and then we could just use our calculator to do all these. But our goal here was to find these without using a calculator. So, for example, when you see division, you know that this is really just log base a of 2 minus log base a of 11 by the property, the quotient property. Well, from above, you're told that log base a of 2 is equal to 0.301, and log base a of 11 is equal to 1.041. So this expression is simply the difference of those two. We should be careful. It's approximately the difference of those two, because these values themselves are approximations. So it's like a double approximation here, in that we're subtracting approximate values. But this would be an acceptable answer, and this is what we're looking for in this problem. For multiplication, it becomes a little trickier in that it's not as obvious which of these numbers are up there. Although I bet you're sitting there thinking, well, Eric, I know that 2 times 7 is 14. And then I know that log base a of 2 times 7 is the same thing as log base a of 2 plus log base a of 7. And then you're like, well, yeah, look, log base a of 2 is 0.301 and log base a of 7 is 0.0845, and my calculator can add those for me. I probably should be able to do this in my head, but whatever. Don't judge too much, just a little bit. I end up with 1.146 as the final approximate answer for that one. Okay, 98 is a little more complicated. I happen to note that log base a of 2 times 49 is the same thing as 98. And then I also know that 49 is just 7 squared. So I could rewrite this as log base a of 2 plus 2 times log base a of 7. There are other ways to do this, by the way. You don't have to do it exactly this way. But this is a nice way, I feel like, to get our approximation. Again, I'm now just plugging in the substitution of what each of these are equal to, which you couldn't see, and then shamefully using my calculator to get the value instead of doing that in my head. There's no shame in that. Don't be shamed but if you do that too. The last one is a very tricky one that can often get people. You might want to treat this one as if it's the same one as a and do the subtraction. But note, it is not log base a of a quotient of two things. It's log base a of 2 divided by log base a of 7. So here we just directly substitute in 0.301 over 0.845. So 0.301 divided by 0.845, that's approximately equal to 0.356. This, by the way, is an application of the change of base formula. What we're kind of asking here is what is log base, let me make sure I get this right, log base 2 of 7. Let me double check that that is the same thing. So what I'm going to do here in my calculator is I hit math and I go down to log base and I'm saying 2 of 7. Hopefully that's really close to it. Nope, it's not it at all. Oops, that's because I put in the wrong things. Oh, thank goodness I didn't screw up. Yeah. Ha. Now note it's a little bit different because these values are approximated, but that's close enough. 0.3562, 1. Yeah, we're really good. Okay, so the last example is noting those special properties. So when I had log base a of a, that was equal to 1. Well, I can extend that. Notice this is the same thing as 3 times log base a of a, which is really just 3 times 1, which is 3. So anytime you have an exponent within a logarithm where the base of the logarithm matches the base of the expression, you just report the exponent. It's 3. I'll do this one longhand again by applying the exponent property, and then showing that when we take log base t of t, that's just 1, and then that's just 2713. But the shortcut is just say, oh, the answer is 2713. So when we do this one, earlier we stated these are inverses, so the answer is x cubed, but let's look at y. Remember our expression from before. Where should I write this? I'm going to write it right here on the side. We know that log base b of a equals k is true if and only if log base b of a is equal to k. I switch these around. I'm putting the k here and the a here. Okay. All right, let me try again. That was an epic fail. So we're having b to the k equals a is true if and only if log base b of a is equal to k. I'm going to use this property on my question C. So my question C is in this form. I'm going to rewrite it in this form so we can see what's happening. So note, we're saying this is equal to some value. We'll call it a. So we're going to take log, the same log as this, so log base e, which we would write as natural log, of a is equal to that entire exponent, natural log of x cubed. Well, in case you're forgetting, remember log base e, we're really never write in this course. We actually write ln of a equals ln of x cubed. Well, in order for this to be a true statement, this a inside the logarithm has to equal the same thing as what's inside this logarithm. So the answer is just x cubed. Now that's a long process to show you why when you see e to the natural log of x cubed, these pieces essentially undo each other, and this is the answer. So as long as the base of the exponent matches the base of the logarithm in the exponent, the answer is whatever we're taking log of in that exponent, in other words, w. So that one's w, this one is just negative k, and this one, oh, careful, watch this. I'm going to rewrite this square root as b cubed to the 1/2 power. I will then apply my properties of exponents and rewrite that as log base b of b to the multiply these two, so 3/2. And then because these bases match, this answer is just 3/2, just like our previous problems, and you can't see that. And that's it. Congratulations. We've done 5-4. Be sure to bring any questions you have on this to our live lecture times during our normal class hours of 6 to 8:30.